Hello, my name is Eran Gilad, and I'll present our paper called EvenDB, Optimizing Key Value Storage for Spatial Locality. Key value stores are databases that store key to unstructured value mapping, supporting put, get, scan, and delete operations. When the access pattern to various keys is skewed, some keys are harder, namely accessed more often than others. In some cases, access skew involves key ranges rather than single keys. This happens when, for example, keys are composed of multiple attributes. In one of our production systems, keys are composed of application names and timestamps. Application usage has a heavy tail distribution where 1% of the apps contribute 94% of events. Since keys include both app name and timestamp, this means that 1% of key ranges contribute those 94% of events. LSM trees are the most common architecture for key value stores. They organize data in levels of increasing size and with overlapping ranges. Over time, levels that get full are merged into levels below them in a procedure called compaction. While compactions are I/O efficient batch operations, they are driven by time of updates and not by the location of the updates. As a result, compaction might process hot and cold ranges, increasing write amplification. Further, in LSM trees, ranges are fragmented across multiple levels and files, making scans less efficient. EvenDB is designed for spatial locality workloads. Key space is partitioned into chunks, which are much smaller than conventional shards, but larger than blocks of data or pages. A chunk index stored in memory provides the entry points into data storage. Each chunk maintains its own storage, containing both a sorted table and a log. This means that both lookups and maintenance are done per chunk. Further, hot chunks cache the data in RAM using a component we call Monk. Monks are suited for range queries and serve both reads and writes. Hot keys that are not part of hot ranges are stored in a global row cache. We evaluated EvenDB using production traces, standard YCSB, key-based benchmarks, and extended YCSB range-based benchmarks. We compared EvenDB to RocksDB, which is a state-of-the-art LSM trees. On production benchmarks, EvenDB ingestion is much faster and incurs much lower write amplification. The results of scan benchmarks are more nuanced and depend on database size and creation phase. On YCSB benchmarks, EvenDB is consistently faster on range-based benchmarks and at least in par on key-based benchmarks. In summary, EvenDB introduces a novel key-value store architecture. The chunk-based arrangement is better suited for spatial locality workloads than LSM due to the lower write amplification, the use of a single level of storage with no overlapping, and the use of memory for both reads and writes. As a result, EvenDB outperforms RocksDB when workloads exhibit spatial locality or most of the active working set fits in memory, and is in par otherwise. We demonstrate those advantages using both real and synthetic benchmarks. See paper for details. Thank you for listening.